I can't tell if this is doing anything. I won't leave. All right. Is this worse than this? Is this any better? Put your hand up if you can hear me slightly better. Oh, that's not bad. All right, I'm gonna keep it. All right. Today we are gonna do JavaScript. So you've learned HTML so far. You've learned CSS, and the last component of the basic front-end development stack is JavaScript. JavaScript is a very useful language because it runs on the web. So it's the only language that runs on the web. Well, there's one more, but irrelevant. So it's a very useful language because even though the language is not beautiful, like you'll find out soon, it's a pretty shit language when it comes to like how pretty and how well built it is. It runs everywhere, so you want to know it on phones, on laptops, anywhere you want. You build it once, it runs anywhere. Great. So we're going to JavaScript, and JavaScript also now runs natively on like you can build desktop apps with JavaScript too. So you can basically do anything you want with JavaScript. We're going to teach you to make websites with JavaScript, which is what it was made for. And later on, we will go into React, which is even more JavaScript. It tries to fix JavaScript because it's a little bit shit. And then eventually we'll get into backend. All right. JavaScript 1, basic JavaScript. So this is a good question because so far you've learned HTML and CSS. And while that is code, you'll notice that HTML and CSS doesn't have like if statements or anything like remarkably useful. That's where JavaScript comes in. It allows you to like basically code like Python. So actually, I'm curious, raise your hand if you are familiar with Python, like you've done at least 3 weeks of 61A or just know Python. Okay, nice. It's like almost everyone. So I'm gonna kind of assume it, so a little bit faster. But actually, you don't even need to. As long as you know any programming language, you'll be chilling. If you don't, you'll also be fine. A little bit less fine, still fine. So do not worry. Yeah, so code, hopefully you know what code is. It's a thing computers understand. All right. So this is what JavaScript looks like. It has like some like string syntax, like const, but overall it's a normal programming language. It's C-like, which is Python is also C-like. So you'll find it familiar. It's not like if you're familiar with Scheme, it's not like really weird like that. It's a normal language. So I'm going to show you here a quick demo. Okay, it's almost invisible. Yes, actually, I'm not sure. Well, am I recording? I am. Yes. Oh, yes. Nice. All right. Nice. Okay, so you have a normal HTML file, right? You can have like stuff in the body, and you have like this stuff over here, which you never know exactly what it does, but you need to put it. And here's what it looks like. Let me remove this a little bit. So this is what it looks like. It's a 42 because I put a 42 in the document. So how do you run JavaScript on the web? It's very simple. Just like when you want to run CSS on the web, you use a style tag. For JavaScript, you use a script tag. And in here, just like CSS, it's not HTML anymore. It's a different language. It's JavaScript. So you can do stuff like kind of similar to Python. So you can be like exactly like that. See, GitHub Copilot over here has told me to do let a equals 42. I'm going to ignore this line. And we're going to do console. Damn it. Console.log a. So this is how you make variables in JavaScript. Same as Python, except you have to say let. Just for fun. I don't know why they put it like that. And so in JavaScript, actually, it gets a little bit more complicated than that. So you have let, there's 3 ways of doing it. You have let, you have const, and you have var. So var is the old way, not used anymore. Let is a new way. And if you do something with const, it can never be changed again. So over here, you see it says const. That means that you'll never be able to change the yearly rate again, even though it's doing it. I don't think this will run. Hopefully it doesn't run. But oh no, it's making a different variable. My bad. So it makes monthly rent and yearly rent. So it's 2 different variables. Both are constant. Yeah.
What is the difference
There is very like almost no difference at all. Like it's a slight difference in scoping. You'll never notice it. The difference is that we made var immediately, or like we made. I mean, like it was made before I was born. But someone made var originally, and now it's used using. They changed it to let. They just like updated the language, and they're like, now you should use let. But for it to work for all projects, they kept var. Just like random. It's not important. Okay. So you make variables using const, var, or let. So yeah, so you make variables. Cool. So it's like almost the same as Python. Now you can do like const a, let b equals a plus 4. You can do var m equals b plus 3. On older tutorials, you'll notice they use var, but in newer tutorials they'll use let, etc. Yeah, you can do everything. You can do if statements, blah blah blah. You can do else statements. You can do literally anything. It's just like Python, except you have the curly brackets. If you're not familiar with the curly brackets, basically the idea is instead of using indentation as a way of knowing, like in Python, it'll be like that. Instead of using this indent as a way of knowing of the fact that it's in the if statement, it uses a curly bracket. That way it doesn't matter where it's indented. So everything in this curly bracket is in this if condition. Is same as Java. I don't get it. All right, comments are like this. There's a comment, this won't run. Oh, shit. So in Python, you actually, I don't know if you knew this, but you can add a semicolon at the end of your statement. You're just not supposed to. It's like a convention, but they allow you to put semicolons. In JavaScript, it's the opposite. So you should put semicolons, but you don't need to. So you're feeling lazy, you can just say, you know what, fuck it. I'm not gonna put any semicolons. And that's totally fine. The compiler, the interpreter will run your code. But you should put semicolons. It's convention to put semicolons. You should. That's it. Thou shall use semicolons. Any questions? I've been told I should ask for questions more. I'm gonna do that. I have uncomfortable pauses too, because I've been told people take some time to. Yes. We have a separate JavaScript file connected to our SDK. Fantastic segue into, well, I was going to go into it later, but order is irrelevant. So if you grab this, you get rid of it, and you just like sort of like close up the script tag like this, and you add a source here. This can link to different files. You can be like JS, same vibe as CSS. It's a little bit different because instead of like changing the style tag into a style with source, you make a whole new link tag. But like it's the same vibe. And you have the JS over here, and the JS is now over here, and that should still work. So you might say, all right, so this is great, but like, what does it do? Like if I go to the page, right? Nothing's happening. It's still my saddle only 42 over there. But if I open the inspect element tag, which I showed you last time, you can do by right-clicking and inspect, and you go to the console tab, this is where JavaScript runs. So on first sight, it may seem kind of useless because JavaScript is running over there, and like that's pretty useless. None of your users are going to open the inspect tag to look at this. But eventually I won't teach you. Next lecture will teach you ways to use JavaScript to interact with the page. There's some things like you can do. I'm just gonna show you a sneak peek. Document.body inner HTML equals 42. So well, there's a terrible example because so if I do 95, I reload. So I don't know JavaScript very well, apparently. Hold on, I'm literally right. What the fuck? All right. Oh, classic novice mistake. So this is not relevant for this lecture, but where you put the script tag does matter. It's not like CSS where you can just slap it wherever you want. You have to put it like where you put it is where it runs. So this script tag will run before this body tag even like starts to exist. It's not that relevant to you right now because I'm not going to teach you any like many methods that interact with anything, but this one does. I'm saying it's documented body to HTML was 95. Now it's 95. It changed to 95. So there is like the point I'm trying to get is that I'm going to teach you a lot of stuff, and next lecture we're going to teach you how to use that stuff to interact with the website like that. You should use camel case, not another convention is you should use camel case, my var, like that instead of my var. Oh yeah, sorry. Yes, this one. Oh, it's not that relevant yet, but this one cost the 42.95. Don't worry about what it's doing. Just know that this is changing like the entire HTML to be 95. Cool little thing. I'm gonna keep it there just for fun. But the point is, you should name your variables like this. I'm gonna do one more, and I'm gonna ask for questions. Types. It's just like Python. You can just put any variable to any type. It doesn't matter what you're doing. You can be like, let my var equal this and that other bar equal, like, and then you can run a string, my string, etc. You can do basically, you can make anything equal to anything. It doesn't matter. Numbers, you can add them up like you do. Strings. Oh yeah, you can have strings with double quotes. Yep. Oh yeah, you can. It's like this. It's literally the exact same as Python. You just have like this over here and over here. They can be like combined. I can just add them like that, and this will concatenate. It won't crash, which it does in other languages. And you know, those of you who are familiar with F strings, you can have that kind of vibe here too, where like you're like my var 2 equals, and then instead of F string, you use these quotes. These quotes are different than normal quotes. I don't know if you can see it from wherever you're sitting, but they're different. And you, in order to put them, yeah, you can figure it out. I don't know where it is in your keyboard, but quotes. Nice. Quotes, and then in here, using this notation, you can insert like some variable, my var. Oh, something that's cool that is not a Python is if this is a number, right? And you put it in here, or like in Python, this would actually work, but quotes plus my var, right? This wouldn't work in Python because you have to like cast and stuff. JavaScript is this awesome automatic casting that will like it doesn't matter. You can add a number to a string and it'll just concatenate it. You don't need to tell it to convert to a string. This will come to haunt you in the worst moments, however. So yeah, look forward to that. Booleans, same as Python, except to spice it up. We don't capitalize the T's or the F's. We just do all lowercase like that. Cheers. There's no not in JavaScript. You can't be like, let other var equals not my var. This won't work. JavaScript doesn't speak English. It speaks math. So you have to use the exclamation mark, which means not. So this will be true. Okay. Any questions? Are you sure? Not equal. Not equal? Well, what do you mean? Oh, not equal. Yes. Good point. False. That's a string. I'm really good at terrible examples. Lamau. So if it's not equal to Lamau, this will be whether or not it's not equal to Lamau. I'll go into the statements in a second. Yeah. It does not take and. Wait, let me get to all that now. Perfect. That's okay. Okay, yeah, well, you know what? I'm just gonna do that right now. So you have if statements. If statements look like this. If my var equals Lamau. So this is the same as Python. Not equals, not the same. You have to use the not. So like in Python, it would be not like, oh no, this is Python. Slow down. This not equals is fine. You can do and. That's not how you do and. That's how you do it in Python. This is how you do it in JavaScript. 2 ampersands. 2 the bars means or. Same as this is all the same as Java, by the way. So if you know Java, you can just internalize same as Java. It's very similar, just called JavaScript. This is very similar to Java. These are all of them. Equals, not equals, more than, greater than. In JavaScript, they have this thing where they do 3 equals. So what this means is that my var doesn't need to just, it means strict equals. There is such thing as non-strict equals, which is the normal one. You should get into the habit of using these strict equals. Specifically, what it means is like if you do this equals false, I'm almost sure this will be true, as in like, well, let's just try it. See, so this is true. This is true because this is false, and when this gets coerced into a Boolean, so JavaScript can compare it, this also gets coerced into a false. So this JavaScript says this is kind of close enough is what JavaScript is thinking, but we disagree. So we do that 3 equals. That means they have to be exactly the same. So you should get into the habit of using 3 equals and nothing weird is going on in your code. Beautiful. Oh, here's the example. So x is 5, but x is equal to the string 5, which is maybe not what you want. So you should just get used to using these strict equals. If statements, I showed you. Oh yeah, print. Print is pretty useful. So print is like that. Console.log instead of just doing print. And this will print on here. So not on the screen, it'll print in the console, which only you can see. So unlike Python, you can't really print things to the user. You print things purely to debug. That's why it's like kind of weird to do it console.log, because you're not supposed to do it very much unless you're debugging. It's not like print in Python. And you can do other cool things. I'm teaching you this. This is an extra tidbit. If you do warning, it's yellow. And if you do error, it's red. Pretty cool. While loops, same as like almost every other language. While condition, this, etc., etc. You can be like, yeah, okay. Hopefully, I'll just here it is. While, so you have friends party equals 0, and while it's less than 10, you just like increase by 1. So you'll end up with 10 friends at your party. Yeah, pretty straightforward stuff, similar to the other ones. And I'm pretty sure it's almost exactly the same as Python, apart from these curly brackets. Oh, I did skip a part, which is so you know how in Python you can do like my var. So this is the way of doing it, right? If you want to increment a variable, you just set it equal to itself plus 1. In Python, you can do this. Right? So you it's the same thing. Plus equals 1. It just adds 1 to it. And in Java and JavaScript, you can do this, which means add 1 to it. It's very useful because often you just want to add 1 to something, so you just do 2, add 2 plus signs. Functions. Functions are very useful, and yeah, you should use them. They work like this. Function 1 goes like that. So it's very similar to Python again. I've said that a bunch of times already. But instead of def, you use function, and you use curly brackets instead of 2 dots. It's like the same vibe as everything else I've said in this lecture. And you do like that, and like that. So what this would do is you run function 1, and it logs out 42. All right. Any questions? Yes. Yes. Return 54. You can return, and you can like result like that, right? So this function prints 42 and then returns 54, and then you have result. Oh, something cool you can do in JavaScript is if you want to see like what result is equal to, you can go in here and just like type it in, and it'll tell you. You can access variables that are in your that you used in your code, which is pretty cool. So you can like debug like that too. And you can also just type stuff in here. So like if I want to just run it, I want to run my function 1, I can just run it. It's kind of like you've probably done this in Python where like I don't know how to do it, but you run your code and then you can like interactively like modify it. All right. Yeah, there's an example. Greek Yeah, I just run read and it returns a string using the f string kind of thing where it like adds composes the string and it logs it. All right, so demo, I've been doing the demo the entire time. Built-ins. Yeah, so this is like this is like in Python is like a shit ton of like things of the methods you can use to like manipulate stuff. For example, I used one earlier. It's actually I'm just gonna do everything in the console. So it's the same. So if I do something in the console, you can do it in real life, in like not real life, in the JS file as well. So you can do like a lamao and dot length. So it's 4 characters long. So I did dot length on the string object and it gave me 4. That's an example of a built-in. Other things you can do is if you have a string, you can do 2 lowercase. Is that it? All right. Well, there's a lot of other ones, I promise. For example, 2 uppercase, you can do that too. And there's just a lot of stuff you can do. Basically, every time you need to do something, search it up to make sure JavaScript doesn't have just a function for it. Data types. Okay, yeah. So even though there's no data types, you can do type off in order to figure out what a data thing is. So, like for example, let hello equals 42. Type off hello number. Type off lamao string. Type off list object. Weird. Yep, that's how it works. Type off dictionary object. Type off. You get the vibe. If you want to know something's an array, you can do array, whatever. You can search stuff every time you need it. But yeah, so like you can kind of like everything does have a type at the end of the day. You can check what it is. Cool. Objects. Objects are where this language gets really cool or really weird, depends on like what perspective you take. But so in JavaScript, everything is an object. There are no primitives, unlike in other languages. Or primitives exist only for like a really short amount of time and become objects. So for example, if I do 50, right, that's an object. So of course there's some methods I can call on the object, like, I don't know, these are all pretty useless because I chose a number about length, right, for example, 2. So everything is an object, but in JavaScript, all an object is if you're thinking in JavaScript terms, a dictionary. So like in other languages, an object is like a class. Well, in JavaScript, it's a dictionary. Let me show you an example. So I can have my object. So just like in Python, I would just define a dictionary. I do curly brackets. And I can do lamao 42 just like that. So my object here is a dictionary with 1 key, lamao, and 1 value, 42. Hopefully you've done Python. This should be pretty similar, except for the fact that you don't need these. You can just do that. Yep. Beautiful. You can nest it. Obviously, you can do like lol. You know, Copilot wants me to use 16. Lamao 42. So you can have like a list within a list. Yes, you can. There's a dictionary within a dictionary, but you can have a list and a list inside, and like dictionary and another lamao. You do whatever you want. The world's your oyster. It's a very good question. The answer is nothing would like happen. It's okay because you define the lamao variable. Yeah, this is just not using that name, even though it kind of looks like it is and it's kind of similar. It's actually like this. You can think about it like that. So it's just the key value, so it's chill. Any question? Yes. Yes, they are. As in, I think the question is like something like this, right? You can like, can you do this? Yes, you can. This is how you would access the dictionary. So let me just show you how to do that. So if I make this object, right, my object, whatever, and then I go here, I reload the site, so it like runs this JavaScript file, and now I have my object available. I can do my object, and just like in Python, I can do lamao. So this will return 42, right? Because again, the key lamao corresponds to the value of 42. And but what I can also do is just dot lamao. So this looks more like notation you would use to like access a method property, right? Like if you an object property, as in if you have a class and you want to see, for example, you have a class dog and you want to see its age, you would do dot age. Well, with a dictionary, you will use this notation. My point is that in JavaScript, there's no difference between objects and class objects. It's all the same thing. So if you have an object, you can do .lamau, and this is an object in the sense of it'll make more sense later. The point is you can do .lamau or lamau. It doesn't matter what you do. It's cool either way. And here I can do my obj.lol, .lamau, first item, .lamau. I got my 42 from in there. Yay. Beautiful. All right. Yeah, so here you can see you define a person, and then you can define a person, and it has all these things about the person, and you can grab it however you want. And here it runs it. So you'll notice here it's using JavaScript like in the command line. You can also do that, same as Python, except it was made way later. So instead of it being called Python, it's called Node, because Node is the interpreter for JavaScript. Yep. JSON. JSON stands for JavaScript Object Notation. It's so there's several ways of structuring data in files. One of them is JSON. There's other ways, like maybe you've heard of YAML, YAML, or actually HTML, XML is one way of structuring data. So actually a lot of people, instead of HTML seeing it as a coding language, they just see it as a way of structuring data, because there's no logic here. But the point is there's many ways of structuring data. And one of them is JSON. JSON looks exactly like this, except the keys need to be strings. It's like the randomest difference ever. But you have to make them strings for it to be valid JSON. JSON was invented for JavaScript. And let me show you an example of JSON. Yeah, hopefully. Yeah. Okay. Yeah. See. Okay. Over here. So you have this object, and you can turn it into JSON, and all that changes about the object is the keys have the quotations, right? So for it to be valid JSON, the keys need to be in quotations. What is the point here? The point is JSON is awesome because it works almost anywhere. It's super portable. So for example, in Python, you've probably used JSON before. You can import a JSON file, and then it'll like create a dictionary with arrays and dictionaries inside of it, and you can export it, etc. And JSON is really important. It's the main way that the server and the main way the front end communicates with the back end. So later on, you'll be like writing backends, and the only way to communicate usually is by sending JSON files to each other. So you have to get really familiar with reading JSONs, and you can just think of a JSON as a dictionary with lists in it. Well, that's not necessarily list in it, but maybe lists in it, and maybe more dictionaries. Cool. Next is arrow functions. So arrow functions are just like functions. So we have a function over here. If you have a function, you can make into arrow function by just doing like this. So let lol equals and this function. So I just did a bunch of stuff, but nothing actually changed. So wait, let me just. So as you can see, different notation, same functionality. This does the same thing as this. Similar thing to Lambda functions. If you know about that in Python, you've gone there. So the difference is that this makes a function, and this is more like making a variable which happens to be equal to a function. But all this does is make a variable happens to be equal to a function, so they actually effectively do the same thing. There is like slight differences in terms of what the functions, like the context of the functions, but that's not important for you right now. What matters is that this is shorter to write than this when you don't need to give your function a name. So just like Python, you can pass in, you can pass into functions other functions like this. So you run lamau, and the first argument you pass into lamau is a function, and here you have a function, and this lamau function runs your function, whatever function it got passed in. This is called functions being first-class citizens. It means that they can be passed around and treated like variables. Pretty cool. And this is easier than defining a function above and then passing it in. This is cooler and easier. Yeah. What do you mean by you can't call it?
Like, are you assigned to a variable?
Mhm.
Like, you can, like lambda functions, you don't really, everyone is saying it, but
Uh-huh. So to my knowledge, you can call lambda functions. You mean,
only is a much simpler way of doing it, like shorter way of doing it.
yeah, it's just straight up a short way of putting it. Yeah, I can show you a lambda function. Lambda function looks like this. Well, it has to do something because it's Python, but like here, honestly, I don't remember exactly. I think it's like this, right? So if you were to type this in Python, it would work. You're passing in a lambda function into lamao that returns 90. You can like, it was something like this, you know, x, y, something like that. So it like takes in x, y, and it returns 90. Here, what you would do is you would take in x, y, and then you would return 90. Does that make sense? Same thing, different language. Yeah, any questions? Still brewing? All right, no questions. Arrays. Well, I kind of already went to arrays, but it's the same thing as Python. So unlike Java, where you have to make array lists or arrays, or like you have a bunch of different things. If you're familiar with Java, you don't need to worry about it. It's exactly like Python. You just make an array, slap some stuff in there. Cool, array, 4 things in it. You can have B, C, D, lots of arrays. You can make an object. You can be like, I'm gonna have lol equal to A here, and B equal to C, just to mess around a little bit. Yeah, so it's similar to Python in terms of how this works. I'm trying to think of any differences or any questions. Cool, yeah, I'm pretty sure it's exactly like Python. Yes. Are they mutable? Yes, they are. There is no such thing as a tuple in JavaScript, sadly. You can mutate anything you want at any point. There is, so I can do that. Well, that's unnecessarily complicated, but I can do that. A2 equals 5. So I'm changing the third element to 5. Also 0 index, so this is the third element. Let me think what else is relevant here. There's something called object.freeze, which is completely unnecessary information for you right now. But if you do it, you can't mutate anymore. Pretty not useful for you, but cool to know. Maybe, I don't know, possibly. Oh yeah. Yes, there is an odd concept of classes, but classes were actually implemented later into JavaScript. It wasn't object oriented at the beginning, so classes are actually just objects. I'll get to it in actually possibly maybe. Oh wait, no, it's almost over. Okay, well, there's a lot of time left, so maybe I'll go into classes. So you have arrays, and the spread operator. Oh yeah, this one's pretty cool. So imagine you have an object, A1, B2, C3. Wait, hold on, what am I doing? Oh yeah, so what you can do is you want to make another object, right? And you want to make this object equal to like the same as object. So you could do this, right? Now, the problem is if you change another object, like A, you change to 4, it's possible object will change. Who here thinks object would change? Raise your hand if you think that if I do another object.a equals 4, the object A value will also change. 2 people. Almost 3, not quite. All right, almost no one thinks this. I don't know why. We will find out soon if it's the case. So I ran it, so the code has ran, so now I can check another object. As you can see, another object is just like object, except a is equal to 4. And if I check object, it also changed. A is 4. So this may be familiar to you from Python. The idea being that when you set a variable equal to another, JavaScript doesn't, it would be too processing heavy for it to make a copy of the entire dictionary, right? There's a lot of things. This dictionary could be massive. So it's too processing heavy to make a copy every time you assign something to a dictionary. So it just actually doesn't. It just keeps the same dictionary in memory, and then object and another object are pointing to that same dictionary. So if you change one, change the other. How do we fix this? What you can do is you can just, like, I don't know, eat it up and fucking type it again, right? But that's not replicable, because imagine you don't know what object is, but you still want to make a copy of it. Well, good for you, there is something called the spread operator, which does it. This makes a copy. So now if I do this, their object change as expected, because we changed it, but object didn't. It's still 1, 2, 3, which is exactly what we want it to be. So that's the spread operator. So you might say, like, why isn't it just like object like copy or something like that? Something that's more user friendly than this garbage. The reason is this is more powerful than what it seems. Because what you're really saying with the spread operator is copy all of the things in here and put them in here. Or in other words, I can actually keep going. I can be like D is 5 and et cetera, because all this is saying is copy all this and put it here, right? So I can keep going. I can put this before, I can put it after. Spread operator is really cool and versatile. And what I can even do is I can say A equals 1, right? But if I set A to, like, I don't know, 3 here, and then I do a spread operator object, it's going to copy this over and overwrite the A. Well, if I put it later, I can not overwrite. It'll be 3, and if not, it'll be 1. You get the idea. The point is spread operators cool. Spread operators cool because it allows you to, like, sort of like figure out, like, I want to copy all from objects, and I want to set A to 3 or et cetera, et cetera. If you're copying like multiple objects, you can be like object 2, and I care more about object 2's values. So object 2 has a value, a key pair that's also an object 1. I want to keep object 2's, etc. Yes. You mean like make 2 copies? So you mean something like this? Like, so I make another object and then like another object? Yes.
Do you do another object equals object.copy or like object select or something?
Oh, so like in order to so do you want another way to copy it? So I think there is a couple of ways. I think you can do, for example, slice, the one you mentioned. I'm pretty sure if you do this will copy the whole thing. I mean, you mean like different ways of copying, or like what do you mean exactly? So this would do the same thing.
Or like set out to copy to something and the one
Oh, I see what you mean. So like, imagine you actually are in this situation and you want to just mutate 1. Yeah, I guess what you could do is there's basically no easy way of doing it. You could make another object a copy of itself and then change it. Yeah, I see what you mean. There's no like shortcut to like say, I want to edit it now, only now I want to make a copy because I edited it. Yeah, unfortunate. That's just life. JavaScript is a shitty language, and we'll keep noticing this over and over in your JavaScript careers. Let me think of anything else that I've sped around through, and if there's any questions. Yes.
Since that the spread operator only goes power copy,
True.
so that means that if you have like another object, if they're using an object, then that is still mutable.
Yes, it wouldn't not mutable. It would, Yes, I guess it would still be the same object. Like, there's actually an important detail because this will happen to you 100% when you're dealing with really large JSONs. So this object has A equal to 1, B equal to 2, C equal to this other object with D equal to 4. If I do this, and then I do just here D equals 5, this will change both another object and object sees these values. Why? Because it didn't like the spread operator doesn't copy it like you would. It just goes through each key and sets it equal to that value. So when it goes through C and sets it equal to this dictionary, it's the same thing you were doing when you were setting something equal to a dictionary. It doesn't actually copy it because when you equal something, it doesn't copy it. It just like sort of like remembers that both of these variables point to the same thing. So while you've copied C, you haven't copied what C points to. And the point is, as he said, it makes a shallow copy, not a deep copy. Shallow copy, only the first thing you use. Deep copy copies everything. There is no easy way of doing a deep copy in JavaScript. They're also very expensive, so you try not to do it. I did miss something pretty important. If you have this and you want to export it, you can do json.stringify obj. This will output the JSON version. Let me just run it. So I have obj. This will output the JSON version. As you can see, it's stringified the whole thing. A equals 1, B equals 2, C equals object, D equals 4. And if you have this string, so I put the string in S now. I can do JSON.parse S. This will take the string and make it into a JSON. So here I have the JSON, so I can do like J equals this, and then I have J again. Oh. No. There. So now J is a dictionary that came from the stringified version of the JSON. Point being that if you want, like, for example, if you have an object that you've made and you want to copy it or store it somewhere and then use it somewhere else, you can stringify it, copy it, and parse somewhere else. Pretty straightforward. This also, believe it or not, makes a deep copy. So J over here has nothing to do with my original object because it was text at some point. And when I parsed it, like, there's no way J could have known that this eventually actually came from somewhere else. So JavaScript can't cheap out and it can't put them in the same memory. So they are different objects. Deep copy, pretty cool, different than shallow copy because D is actually unique. Yeah, my camera's gonna finish the argument so early. Any other questions? Yes. Yes, so we will go into exactly how to do that later. By later I mean in the next class. That's what the entire next class is about. But if you want to just start having fun in order to do something, you can do document.body.inner.html, and then whatever text you pass into here, the entire thing in here inside the body tag will become what you pass into here. So if you do something like that, lol, like that, this will work. This will set the entire document to an H1 with lol in it. So you can be like, oh, something else you should know, which is pretty cool, so you can start having fun, is alert, prompt, and confirm. Search it up in your own time, but I'll just show you prompt. So I'll show you confirm. If confirm, are you okay? Mental health is very important, and this is going to ask you. So, are you okay? Hopefully, yes. And then set it to, oh, yeah, not a good message. But you get the idea. You have if confirm, are you okay? So this returns true or false depending on what you do, accept or cancel. And then because it was true, it sets the inner HTML to lol. Cool. Yep. Any final questions? All the way back. Functions are passed by reference. Yes. Yes. Functions. So if you pass something into a function, it'll make a copy, just like assignment, same vibe. So you have lol over here, it takes an object, I run lol, I pass in this object. This will make a copy of the object. Yes, I'm just gonna say yes. I won't get into it. Yeah. Any other questions? Yeah.
How do you know?
So here. So triple equals will say if it's exactly not equal to, so. Yeah, so the question was specifically triple equals, how do you, like, what's going on in this image? X is 5, right? So X is clearly, so is X equals to the string 5? No, X equals the number 5. Wait, what? Yeah. Honestly, I don't know exactly what's going, because X is equal to the string 5. Oh yeah, of course. So, okay, yeah, makes sense. X is 5 equal to 5? Yes. Is it not equal to 5? No, it's not. Is X equal to 5? Yes, but is X not equal to 5? Yes. So this one's the interesting one here. Is X not equal to 5? You would think it would say false, right? Because X is 5, but because this is in string and this is a number, it says true. X is indeed not 5. You know, you should probably just stick to these ones over here. These are easier. X is exactly equal to 5, and X is exactly not equal to the string 5. This is the same, but flipped. All right. Not a problem. Yes. Explain the difference between double equal and triple equal. Yeah, just one more time. The triple equal means exactly equal. So it'll check the data type first. What does that mean? That if X is an integer and what you're comparing it to is a string, it'll just return false. It's not the same thing. While the single equal is kind of just gonna like feel it out and say, hey, look, well, X, you know, it's 5, but this is a string and it also has 5 in it, so it's kind of the same vibe. So it'll return true, despite the fact that X is a number and what you're comparing it to is a string. So it has actually nothing to do with each other. Does that make sense? Awesome. Any final questions? All right. With that, the lecture is over. The attendance code is any suggestions for the attendance code? I'm gonna go with pizza. And the attendance link, I don't have it. Well, let me get it. Yeah, all lowercase.